Let's go ahead and get started. Part of this, if you're in the 3D game development class, you'll see as a repeat, but I won't do the exact same. So I'll use it as a moment for you to learn other techniques and so forth. First off, we'll go over to Blender, and I got a cube here. I can change the size of it along an axis by doing my S for scale and then pressing whichever letter. So if I do SZ, I can increase it like that. I could drop on I'll do a crate, and I'll drop on a UV sphere for the head, and I'll move it up. I'll do an S for scale and just make it bigger. Move it up a little bit more. So I got a head now. I want to create arms and I want to create legs. You can see I won't be teaching art. If I select this and I go into edit, I went into edit by pressing my tab key. I need to subdivide so I can have something to work with because there isn't enough vertices here. I can select one of the faces. So if I come down here to face select mode, the little cube with an orange side, and select that face, then I can do a W for subdivide, W for subdivide again, W for subdivide again. What did I do? Let me try that again. Okay, so W for subdivide, and that's 1. W again, that's 2. W again, that's 3. Why that's important is because I want to do the same thing on the other side. So I do a W subdivide, W subdivide, W subdivide. There is tools over here where you can subdivide, and you can tell it's like the number of cuts. But I'm just sticking with the basics there. Okay, so I'm going to pick where my arm's going to be. Right-click here, right-click here, right-click here, right-click here. Now, maybe I don't want an arm that big. Okay, just those two, I guess. And I'll do E for extrude. And then I can move that out, and that's my arm. What did I choose? Second row in the middle. Okay, then 3, and then, okay. So I come over here. On the other side, second row, 3 on each side, and I'll do extrude again. So I'll do E for extrude and move it out. Now, it'd be nice if these were the same distance. They don't have to be for what I'm showing, but that's probably close enough. Now I need legs. So I come down here to the bottom. I'm going to do a face select on this. So that's selected. I'll do W for subdivide. Actually, I guess I could show it over here, but I'll do W for subdivide. Am I subdividing that? I don't think I am. I in edit. Yeah, I'm in edit. I got that selected. That's curious. Interesting.
Could it be the amount of subdivide cuts you're trying to make?
Shouldn't. Like if I go to the top here of like that, if I do W for subdivide, subdivides it just fine. Why doesn't it like the bottom? I don't think I've ever seen that before. It's just like this side. W for subdivide. Interesting. But I could do subdivides on this side. Can do it there. Well, let me choose this and choose E for extrude. Move that down. That's a little disturbing.
You were making all those cuts, it just wasn't showing up. Look at how many vertices you've got.
Yeah, that's what I was saying. I'm looking here. It's like I'm seeing all these lines. Okay, I don't know why it wasn't updating. Ah, jeez. Yeah, there are quite a few vertices there, isn't there? Based upon what I've been doing. Let's get rid of some of those. Oh well, it doesn't need legs, I guess. It just does not like me today. I expect I probably have clicked something by accident. It doesn't allow me to see. Well, no, it allows me to see the ones up above. Now, for your project, I'm going to have you create shapes here, like figures and so forth. If you can't make legs, don't stress. I'm not going to grade you that harshly on it. I just want you to create something. Okay. So I got the legless person. Let me, yeah, that's fine. So I'm going to go ahead and save this. And, see. Save it to the desktop, I guess. And I'll call this the legless person. Now I'm going to go into Unity. And I'm going to create a new project. And show how to import a Blender file. Let's see, new project. Legless importing. Yeah, save that. Now, right now, I've saved the legless person to my desktop. Probably been nice if I had noted down the location, but mine is saved in documents. So you just need to write that down when you go into it, because that's what you zip up and turn in. And I'll show that after I've done some of this. Okay, so down here in the assets, I'm going to right click and I'll say import new asset. And I'm going to go to my desktop. And I'll bring in the legless person. Now this not only imports that in, but it copies it to the assets folder. So now if I make any more changes in Blender on this particular model here, it will not be reflected here. I'd have to actually open up the blend file in that assets folder. So if I drag this and drop it up here, then it puts that character there. There it is. Of course, help staff text. No, it wasn't a move tool. You just got to use these arrows. You can rotate this. You can scale it. You can do whatever you want. If I drop the legless person on here again, it creates another one. You can sit here all day long dropping legless people on here. Like that. Each one of these has their own instance. This is like you're creating an object. Yeah, maybe you're going to do a game where you have 50 aliens attacking. You create one model and you put it down here in the asset. Now this asset has nothing to do with what's actually on your scene in your game. This is just what we've put in the kind of our toolkit that we're ready to use. And then you could sit there and you could drag these up here 50 times. Probably drag them up there 1,000 times if you want. And each one of these have their own settings. Through the code, you could access each one of these individually. Well, if you think about like a 3D Space Invaders game, if you had 200 characters going back and forth, you have a lot of code you have to do for each individual one. I think both of you have seen the movement code. You'd have put movement code behind each one of these. Well, we're going to see there's a better way of doing it than doing each one individually. But that is a feature of it. And if you just have a couple, 2 or 3 that are the same, it might be just as easy to add them on individually. Okay, now I'm going to show adding on Turbo Squid. Again, create a free account on Turbo Squid. Don't pay. And for the 3D models, again, you can do the drop down here and choose whichever one you want. Robot. I went to robot. Good thing I didn't bring up any nudes. Should really look at these before I bring them in. Oh, here's what's his face? I can't think what he's off of. Okay, so it tells you what formats they're in. I think this will probably work. We'll try this. It's different than what we had before. Before we had an FBX. Blend brings in, but these should be perfectly fine too, because Unity's set up to work with a lot of different packages. Okay, so I'll click download. Let's see, what do I want? I'm going to choose OBJ. Let's see where that's at. Show in folder. Okay, that's my downloads. I'm going to cut that. And I'll put it into my pictures, I guess. Paste that in. We'll see if it brings it in. Bender. Yeah, Bender's his name. So I come here, I right click, and I choose import new asset. Pictures. And I'm looking for Bender. There it is. That doesn't look like Bender. Oh, guess it does. They had a lot more to that model than just Bender. They had this piece right here. They have a lot of different pieces there. Now remember, when I brought in my legless people, I I had them as separate items over here in Blender. They don't have to be attached. See how my head is not attached to the body. So when you bring in the Blender Bender like this, you're bringing in a lot of different pieces. Sometimes you want those separate. Especially if you're going to programmatically do items with them. You know, if your character's not always going to have its arms out like that and never change, then maybe you want these as all together. Maybe that'd be easier. But if you're going to actually manipulate those, move them around, then you may want them as separate. So in case you're wondering, well, why have them separate? Why not attach them like you did in Blender? The question is if I can figure out what this curve is here. If I can delete it. Delete. This section will break the prefab. Are you sure wish to continue? Yeah, I do. Okay. That looks better. Now see this. Of course, I still got all this, but if I click the main one here, it'll select every piece. So when I move it, it moves everything together. Probably if I look at my legless person, if I expand that, see how there's a cube, which is the main body, and then there's the sphere, which is the head. So if I'm going to design a game where the head pops off, then I probably want those as separate pieces. You notice over here, if I click the cube, cube is selected here, and it's got its own separate items. I could add a script file here. And we'll look at the script here in a little bit. I click the sphere. It's got its own separate, and I could add a script file here. So you can have separate code to control the movement of these. So you could, at a certain instance, have the head pop off. You could have legs rotate. If you think about what walking is, it's your legs moving like that. Now you have to do it based upon a pivot location, but we'll see more of that later on. Okay, so I brought those in. If I look at the game, it might be turned the wrong direction, but that's okay. We're just demonstrating how to add an object. But they're probably floating in space. They are floating in space. You can add a ground to this. And you do that by game object, 3D object, and you choose terrain. You can move the terrain like everything else. You can also change over here the location. Like the X you see is negative 126. I can change that to negative 150. Change the Y. Y is up and down. Never mind. I won't change the Y. Z, I could have it go back to negative 150. I can change the scale on this. 2, I don't want 2 there. 1. Now, since this is flat, it doesn't do anything. There we go. Okay. Now, you can do a lot of different things with your terrain. You can add... Did you have a... Okay. Now over here, if you click these buttons, you can raise, lower the terrain. Come down here in your brushes, and this affects how you increase it. If I click here and hold down, see how it raised to a little hill. These over here will do different patterns. If I click that and click over here, as you just move your mouse, you can get it to achieve even a bigger effect. if you want to drop a texture on your terrain here, then, oh, by the way, you're not limited to just one terrain either. If you look over here, terrain is one of our items. You could add another terrain on there. So don't think that it all has to be the same color, it all has to be the same pattern or anything. It gives you a lot of flexibility on what you can do here. Let me see if I can remember this. Paint texture. And then you need an image drop on it here. So if you right click down here and choose import new asset, if I choose grass, for example, over here, if I click terrain and click edit textures and click add texture, then up here you can grab your grass down here, left mouse click and drag and drop it up here. A lot of things in Unity are that way. You can click and drag and drop them, or you see there's a select option here, and you can then select the grass that way, and then click add. My people here, keep wanting to do G for grab. Maybe they're no, they're on top. That person's down below. Questions on building a terrain?
I've done similar stuff in the past, so none here.
Okay.
I've done similar stuff in the past.
And we're going to see that we're going to see how collisions are handled on terrains later on. We're going to do a lot with collisions. Because your character's moving across the screen, it shouldn't be able to go through your terrain. So we'll see how to go about that. A lot of settings here. When you're working with these, you'll see some of these have different settings also. Brush size, opacity. This refers to how much it affects when you start clicking around. Does it affect the entire terrain, or does it just affect a little piece? Let's see, what am I in? Okay, raising terrain. I choose one of these. Brush size, 100. Then I can create that very quickly. Okay. So that's how to import a character and how to do a terrain. And what I want you to do is to, oh, by the way, if you ever screw up on this, Control Z just undoes it. That's what I've been doing over and over. If you really screw up, you just right click on the terrain over here and you click delete. And the terrain's now gone. And you can start over. You see me start a new game over and over, which probably makes just as much sense just to highlight everything and delete it. But let's see, game object, 3D, and choose terrain. Terrain selected. So my position, -300, -300. That's curious. The update is kind of hinky on that. So now if I have these selected, I'm surprised they don't tell you what they are when you put your mouse over it. But it's just different patterns. Then you can just click and hold down, and you can draw a trainer on there. And remember, you can go over here to your paint, and you can add on a texture. So you click edit textures, click add, and let me see what images I have. So I'll do a right click on the assets, import new asset. Clouds, I guess. Draw up here. Click Add. And so that drops on my my texture and all that. What I want you to do is the project for this class is similar to the last one, except for I want you to create a terrain and create some kind of scene where you put mountains around like this or something like that. Find some kind of clever image to put on here, more than just grass like I did. And then I want you to put on 4 characters. I want you to create 2 of the characters yourself. And I'm sure your artistic talent would be far exceed mine. And I want you to also pick 2 images from TurboSquid. Again, choose free ones, so don't pay for it. That's interesting. There's a dot blend. Let me bring that in. Well, maybe. There it is. Okay. Am I clicking the right thing? Must have exceeded the amount of things I can download. Dot blend. There it goes. It's not doing it right. Okay. Copy that. Cut it. And I'll put it into my images. Paste that in. Or import it, I should say. Although I think you can drag and drop into here. Like if I have this, if I click and hold down, put my mouse over Unity, I can drag and drop it right in here. Some people like to do that. Well, maybe not. You'd add another terrain. Okay, never mind. I thought
No, it's right next to your clouds.
It's what? Oh yeah, there it is. Why do I have 2 terrains?
Because you deleted the first one and you didn't
No, it's
delete
right next to your clouds.
Oh, okay.
You have
I
it
didn't even notice. Okay, so click and drag that up here.
because you deleted the first one and you didn't delete its
And,
asset.
I don't even see it. There's the plane.
Is it?
Although we're not going to cover rotation today, I'll show movement here in a minute. You could have your plane flying around on your screen. So I was looking for something different, but the plane worked out fine. So you don't have to have a simple object moving like I'm going to be showing you. You can program in an object from TurboSquid. Okay. Again, each one of those is a separate little piece. You can delete them individually if there's something there you don't want. As you go through here, you'll notice that some of these have two shaders over here, 2 material blocks. A lot of them just have one. So you're not limited to just grayscale images either. If it's got color over in TurboSquid, when you bring it in, it's gonna have a color. Okay, so let me go ahead and do a new here. Start over. Let's save, I guess. I think I did new.
You did new scene.
Oh, okay. Jeez. I got new glasses too. You think I wouldn't be blind, but I obviously am.
You did
Okay,
new
I call
scene.
this the movement. Now I'm sure there's a way to change this, but I don't know what it is. I'd have to Google it and see. But there's different ways of representing 3D coordinate systems, and they got I don't even. There's some where where you have one's a Y, one's a Z, one's an X, and so forth, and you can rotate them, so forth. Blender has a Z going up. Unity has, I think, Y going up. So you have to be aware of that when you're programming movement. Now we're going to drop on an object here. So I do a game object, 3D object, and I'll drop on a sphere. I want a terrain, so I'm just going to do a game object, 3D object, terrain, and change the position of that. I'll make this negative 150. I'll put the Z as negative 150. Choose a sphere over here and move it up a little bit. Right there. And I'm gonna drop a grass again or Pink Panther on. I need new images. I keep using the same things over and over. I'm gonna drop the Pink Panther on as the background for the terrain or the material block for the terrain. So I'll click terrain. See this one. So that's our what is that? Paint texture. Choose edit textures. Choose add. Drag and drop the Pink Panther on there. Click add. Okay. So we're going to have this ball move around on our screen. So I need to drop a, for the ball. It's I clicked the ball there, but it didn't grab it, did it? Because it's still thinking I'm wanting to do something with the terrain. And that's where you just have to click this sometimes to get it to switch. And I'm going to click add component. And I want to choose new script down at the bottom. And you can call it whatever you want. I don't know if it takes spaces or not. I never have tried that. But see, ball movement. Click create and add. Puts my source code here. I'll double click that. And that double click. Try it again. There. Okay, so our we're gonna have our ball go back and forth. So down here in the update occurs every time it goes through a little game cycle, a frame, and we're going to declare a vector 3. A vector is a structure that keeps track of your position of whatever you're working with. And I want to give it a name like position. Now I'm going to set position equal to this dot transform dot position. Now what that's referring to is this refers to whatever I attach the script to. So we attach the script to our sphere here. So this is the sphere. The transform is this name right here, this transform. The position is referring to the x, y, z. And that's what a vector 3 is. It's a set of 3 numbers you can access. In this case, it specifically labels them as x, y, z. So I could say position.x is equal to position.x plus 0.01, and then I have to put an F here. The reason why is if I put my mouse over the X, it tells me it's a float. Float is a number with decimals. It's different than a double, though, because it's smaller. It takes up less memory. And when you add 0.01 by itself, 0.01 is considered a double. A double is a number with decimals. When you try to add a float and a double, it doesn't like it. For example, if I take off the F, and I forget this about every time, it gives you a red squiggly. You put a squiggly over there, it says cannot implicitly convert type double to float. So by putting an F on here, you're specifically changing that to a float. You say, okay, it's a 0.01, but it's going to be a float. I know that's a little bit confusing, but we'll see a lot more of that as the semester goes on. Now that I've changed the X part, I want to then assign it back to this dot transform dot position. By the way, this is, I believe, optional. You don't have to put the this. You can just put a, I believe, transform dot position, because it assumes this is whatever the is attached to the code file. I can't change because that's the way I originally learned. But Unity keeps improving, and I'll always put a this there. Now let's attach to Unity. So I click this attach to Unity here. What attach to Unity does is it sends the code over to Unity. It says, okay, now you can use it. You'll see the results here. Be nice if it told you when it was done. I always use the gauge. If I can Alt-Tab over to Unity, it's done. And see, that's done. And if I click the ball movement here, I'll see my updated code here. And so then I'll click my start. Then you see your ball moving across the screen. Moving pretty slow. It's moving slow because I'm adding. I need to stop the debugging each time. I'm adding 0.01. If I add 0.05, it'll move faster. See if I change that to 0.05. And I'm trying to Alt-Tab. Again, that's my kind of, there it is. Indication when it's done. And I click play. You see it going faster. Now I want it to turn around when it reaches a certain point. Realize that this right here has our position, X, Y, Z. So when it reaches a certain point, I'll go ahead and stop the debugging there. I want it to go back the other direction. Well, up here I can declare float direction equals to 1F. And then down here, I'm going to multiply this by my direction. So I'll say times direction. And you say, well, you haven't changed anything. You know, this is 1. 0.05 times 1 is 0.05, and I'm adding 0.05 over and over. What I do is I put a check in here. I check to see if my current position of x is greater than like 8. If it's greater than 8, I want it to go back the other direction. So I'll say direction is equal to direction times -1, f. By multiplying it by -1, that's going to reverse direction. Now, each time it goes through this line of code here, it'll take 0.05 times -1, which is negative 0.05, and it'll subtract that from the x. Very simple way to change direction. And here I'll say if position.x is less than -8, I'm going to change direction by, again, multiplying by -1. You might say, well, those are the same thing. Well, think about when it's changed direction. You take 1 times -1 gives you -1. You reach the other side. Your direction is still -1. -1 times -1 is a +1. So then that reverses it. So now if I click Attach to Unity, and there we go. Run that. You see a character or your sphere going over like that, reaches a certain point, comes back. This is all done programmatically. That's still pretty slow. So what I can do over here is instead of hard coding the speed here, I can come up and see if I can remember where to put it. I'm not going to be able to remember it. I'll have to figure out where to put it. But I'll just put it here temporarily. Oh, I know. No, I know how to do it. Public. Public float speed equals 0.05 f. Now down here, instead of hard coding the 0.05 f, I'm going to just refer to speed. Now this, by declaring it up here with a speed and saying it's a float is a number with decimals again, and then speed, we can change it in one place and changes it everywhere in our program. So I can click Attach to Unity. And if I click Run, let's try it again. Sometimes I just start clicking. It's like when I'm waiting and I'm impatient. Okay, starts going across screen there. Still going kind of slow, but that's okay. Okay, so I click the ball here. There it is. When I click the ball, the script that I added down here at the bottom, see how it now says speed is 0.05? By putting the public on here. So by putting this public right here, what this does is it puts it over here so I can manually change it here. So if I change that to 5, for example, and then run that, If I've done it right, you should see it now going quite fast. Doesn't look very realistic here, does it? You'll find that if you start increasing that value too much, then it'll go from here, and the next game cycle, it's over here. And so you don't see the movement in between. 0.7. So that's not too bad. It looks halfway realistic that way. So again, over here, if you declare a variable up here, and it's right after your public class. If you declare one right here, then we're going to see a lot more about variables. So if you're not sure what in the world a variable is, don't panic. We're going to just really go slow through this and make sure we work small examples and keep building upon it, and you'll understand what in the world a variable is and so forth. But if you put a public on it, then you no longer have to come to the code to change it. You can change it right over here. I always have to click to see where it's at. Like I clicked here first, and it wasn't here. So then I knew when I went to sphere, I should see it here. Okay, now there's a website called Desmos. It's a math website. I click Start Graphing. You may or may not have it had algebra, but you can type in like y is equal to negative x plus or negative x squared. Now I'm going to do a caret for the power. The caret is above the 6 squared, and I'll do a right arrow key to get it out of that, and I'll say plus 5, plus 3. Okay, looks like that. I can apply numbers to this. I can put a 4 here. That brings it in if you've studied that in algebra. If I put a fraction in front, it spreads it out like that. Let me put a 8 in here, see what that looks like. Okay, so it looks like that maybe. Let me try 10. 15, 20, 22. Okay, 22 like that. So there's an x squared, by the way, is a U shape. You throw a negative in front of it, it opens upside down. It's like an N. It's like a hill. Let's say I want to program this in. I wanted my ball to follow this pattern here. Well, first off, it's going to screw us up. Well, no, it won't, because y is up in the unity, and x is side to side. So we should be able to use this directly. Okay, so now x is going to change. So that's going to change just like before. But now we're going to program in the y to change. So now that I've changed my x down here, I'm going to say my y is position.y equals, what is equal? Negative 1 divided by 22 x squared. So times my position dot x times position dot x. We haven't talked about math libraries yet about how to do a squared, but what x squared means is x times x. Plus 3. Now there's an issue here. If I do the semicolon there, I'll probably get a red squiggly. Oh, that's interesting. I expected a red squiggly. Interesting. Let's see if that works. The reason why I expected a red squiggly is because the x is a float, and I expected these to be like either integers or floats. Well, let's just attach that and see if it works. May have to tweak this some to get it to work. If it's doing integer division, it's not going to look good at all. So I ran it. Too high, isn't it? I'm not sure if that has if it's going straight across or it's got a little bit of a curve. Yeah, let's change that somewhat. Teach math. That's pretty sad that I have it up too high. According to Desmos, if I'm here at -8, then the y should be about 0. That's why I kept playing with that to try to get that to come out, because at the furthest reaches, then this should be flat on the ground. So it makes me wonder if it's doing this calculation correct. -1, let's say f, floating point divided by 22 floating point plus 3 floating point. Let's see if that's the issue. By the way, this isn't brand new for me. I've never went to Desmos and tried to implement a graph that done over there. That's part of the fun of doing this in class, is experimentation. Okay, now let's try running it. Ah, it was that fact. So you see, I'm achieving a algebraic shape here. This would take me a long time to try to program by moving to this point, and this point. So by putting an algebra equation there, if you hate algebra, well, maybe this helps you appreciate what it'll give you. Then you can create this effect. Pretty much any shape you could envision over here, and Desmos is a fantastic one. I chose 3 so it wouldn't go up too high, because now let's see how high it is. Since we haven't experimented with the camera yet, then I didn't want to go further with that. Yeah, see, there's 3. If I'd went up to 6, it'd probably go up here. Let's try that and see what happens. First off, I'm going to come over and see what my model looks like. If I change that to 6, well, see here at -8, it's going to be up off the ground. So, yeah, you'd think teaching algebra all these years, I'd be able to anticipate this better instead of just sitting there playing with numbers. 12, that's not bad. How about 11? 11, that's even better. You see down here at -8, it looks like the y is about 0. I could play that probably a little bit more. 10.9, 10.8, 10.7. Of course, if I was really interested, I could sit there and probably do algebra, where I set y equal to 0 and find out what the exact x value should be, such as perfect. But it's not worth that effort. Okay, so let's try that. So, -1. Come over here, stop debugging. We got -1f divided by 10.7f times x squared plus 6. And I click attach to Unity. This is not a bad thing to do if you're in a game and you want to simulate like jumping, and you want it to follow a certain pattern. Then you can do something along these lines in order to get that to appear. Now, if I run this, it'll probably be more of an arc when I go through and do it. Might be going a little bit too fast. It might be my eyes aren't that great. But if it doesn't look fluid, like if it looks like it goes from here and then goes down and you don't see everything in between, then that's too fast. Now that the second project I'm going to give you is going to be basic movement, which we'll look at here shortly. And it'll also be for you to implement some kind of algebraic shape, just like what I just did. I don't care what you create. You know, if you want to get real fancy, you could, you could add different items in here. You know, if you put the third power, you know, you could have it go up and go back down type of deal. And it'll handle itself if you've already set up your x values, such that your x values are going back and forth between two values like that. All you have to do is dream your own graph over in Desmos, and you just put it in here. And again, if you put F on each one of those, then that'll handle it. Okay, enough about the movement of that. Let's take a look at some basic movement controlled with your keys on your computer. Okay, so I'm going to drop another shape on here. I'll do a game object, 3D object, and I'll drop on a real exciting cube. And I'm going to move that. Here. Okay, now I want to drop a script on this. So make sure your cube is selected if it isn't, right here. And you can click Add Component here. And if you scroll down to the bottom, you'll see New Script. And again, you can call this whatever you want. Cube Movement. And click Create and Add. Now you'll see these here. You got 2 of them now. And you'll find very quickly, if you get a very complex game, you may have 100 of these. So that's why creating folders, right-click down here and creating a folder and organizing it isn't a bad idea. Okay, so this was cube movement, so I'll double-click this. And that brings me over here. And using the same principles as the other, we're going to declare vector3. I'll call it position. And I'm going to store off the current position of the cube. So I'll say position is equal to this, dot transform, dot position. And you'll notice this is the exact same code I did for the other item. So this will become second nature. Now I'm going to do an if statement. This is going to check to see if they pressed a key on the keyboard. So how I do that is with an input, dot. And if I start typing key, you see the ones that pop up. If I type button, although I haven't done this yet, well, I've done mouse button. Somewhere you can program in like an Xbox controller, so you can use a controller to play it. I haven't done that. That's one of my goals this semester is put that into the class. I don't even remember, somewhere in here in the input is a controller. Maybe I'm lying, but it is somewhere if it's not in input. Touches, I'm assuming that's probably a phone. Joystick, pre-configured, that almost looks like it, but get joystick names. Anyway, I'll play with it before we get to that point. But if I do a dot and then do key, I think it's get key. I look for the one that says auto fire. If you don't do the one that says auto fire, you have to keep pressing your button over and over to get it to move across screen. If you choose the get key and hold down on that key, it will automatically move, which I think is preferred. Now I do a beginning parentheses. It'll tell you down at the bottom what it's expecting. It says it expects a key code. And you just simply type key code dot, and then whatever button on your keyboard. You can program alpha 0, alpha 1. I don't even know what those are. Oh, that's not on your keypad. It's a 0 through the 1 through 0 across the top. You can program individual keys like B, your backslash, your F, your function keys. You can program those. You can program anything on joystick button. Maybe that's what I'm thinking. Of course, step one is for me to go out and buy an Xbox controller. But I'll get there eventually. Okay. I didn't want joystick there. I wanted to do the dot right arrow key. Make sure you have the correct number of closing parentheses. It's very picky. If there's a beginning one here, it expects a closing one. If there's a beginning one here, it expects a closing one. And then I'm going to do position.x is equal to position.x plus 1. Or 1? No, that's too fast. 0.05. Now, when I do a 0.05, just like before, this is a floating point is the x, and this is a double. So I have to put an F on here to convert it to a floating point. Now do another if statement. If input.getKey, key code dot left arrow, position.x is equal to position.x plus 0.05f. Now I can do my up arrow and down arrow. If input.getKey, key code dot up arrow. I don't play PC games, so you'll find most of the times I'm going to use the arrow keys. But part of the project I'm going to have you do, besides simulating a movement of some sort, a graph you see over in Desmos, I want you to put basic movement in. I want you to use the standard keys for a PC game, the AS, whatever it is. No memory. Now, let's see, Y is up and down, so I must want Z. So position.Z plus 0.05f. And input.getKey. Beauty of Visual or C# is that it automatically changes my case for me, so I'm not doing any of that. And I'm typing the case wrong and it's correcting it for me as I go. And position.z is equal to position.z minus 0.05f, like that. Now that I've checked for my changes, I want to write it back out to the cube. So I say this dot transform dot position is equal to position. Okay, so if I attach to Unity now, now if I run that, my ball will bounce back and forth. Sometimes I'm never sure if I actually clicked it. Then I get impatient and click it again, which shuts it off. And then I click it again. Interesting. Let me stop that process. There it goes. And I've obviously done something wrong because my keystrokes are not working. Okay, let me go check my code. Computers come down to a crawl. Let's see if input, okay, right arrow, okay, change that, set it back to that, okay, that code all looks perfect. I don't have to actually have it attached to Unity, that just sends it over. If you're debugging, you do. Okay, so let me try that again. There it goes. I'm doing my left arrow key and it's going the wrong direction now. So let me go check to see what I screwed up there. Probably didn't put a minus somewhere. Plus, plus. Of course. Minus there. Okay, attached to Unity. I'll leave it attached. Okay, so now I run it. Now I'm holding down my left arrow key, right arrow key, my down arrow key, and then my going back, and so forth. So that's our basic movement. Now this right here could be a tank. You know, if you had a model of a tank, you could be using your arrow keys to move it around on your screen. If I fire, we'll be looking at all this in the future. If I fire my tank, a little ball comes out. That's my cannonball, and that's just a game object. So that's an asset that you've dropped on there. Or it could be just a one you've added on there, and that fires across. What causes it to hit something is you're checking the collision, the colliders. Now realize you're just not limited to just the changing the position. Have I done the scale before? But we should be able to do the scale also. For example, if I come over here, I think I got time for this. Might be kind of iffy. But if I keep track of scale also, like I create a vector3 of scale, and then I record off the scale is equal to this dot transform dot scale. I don't see scale. Scale the transform relative to the parent. Let's try that one. Don't know if this will work or not. Rotation's a little bit weird. It's not like what you think with just automatically plugging in degrees and you got it. Rotation you have to change a little bit. But over here, if I then say scale dot x is equal to scale dot x plus 0.01 f, and here I'm setting my position back. This dot transform dot maybe it's local scale equals scale. Let's see if that changes the size. I never have programmed a game where I change the size of the character. Rotation you do fairly often. You have to use quaternarians to do that, but I never have tried scale. Sure enough, it's working. See how my I don't have it on a keystroke, but see how it's changing the scale in terms of the, I think the X is what I did. Becoming bigger and bigger. This would be if you had like if you're trying to program like a Pac-Man game, maybe a 3D Pac-Man. If I remember right, it's been so long. I think that was on a Nintendo 64 or something. I played it. But when you ate like one of the power-ups, I think your character became bigger. Maybe you just changed color. I don't remember. But you can change that. Now rotation is not so easy. It's not just where you can increase this by so much and it's going to rotate like you think, if I remember correctly, which is always iffy. Okay, so the projects we're going to have off that is our first project is going to be created to drop on, remember, four characters and a terrain. 2 of the characters you create in Blender. And again, I'm not expecting a genius in art, so if you are fantastic, you're a lot better than I am. But create 2 of the characters yourself, and you're going to import those into Unity. And 2 of the characters are coming from, TurboSquid. Keep them halfway clean. If there's like a really X-rated one out in TurboSquid, don't use that. So keep it clean. Your terrain, remember you can do different things. You can put a mountain around the outside, but you're creating a scene of some sort. So create an imaginative scene using your terrain. What little you know for the terrain so far. The second project, you're going to use Desmos to develop Desmos to create a pattern of some sort. And if you want to stick with the x squared, I have no problem with that. Remember, the negative causes it to flip upside down. Use Desmos to create a pattern and implement. You can do a ball or whatever, a sphere, following that pattern. Now these are, when I come up with it, just as long as you come up with something that uses the same technique. If you want to go way beyond what I've done, that's fantastic. Don't let my instructions limit down your imagination. And implement character movement using standard, and this should be on a separate object, using your standard keystrokes, whatever those are. See, I don't play PC games. I couldn't tell you. You know, that AS stuff, WASD. WASD. Okay. But those are the 2 projects
WASD.
and they'll be due a week from now. So the 23rd is when those will be due. Is there any questions on anything? In case you're wondering on Desmos, the website is www.desmos.com, and then you go into the graphing. If you do different combinations here, negative x to the 4th, and plus x to the 3rd, minus x squared. That's not very imaginative. Plus 3. As you put different numbers in front of these, you can get different patterns. So you can. I'm using my mouse wheel there, so you can get it to do different things. It's just however much you want to tinker with it. If you do this, I wouldn't try to always go from -8 to 8. You probably just want to go from whatever x value to whatever x value. But yeah, you can play with that. Well, I'm going to go ahead and stop the recording.